Hello, Naomi here. And in this video, I'm going to talk about network topologies. And first and foremost, we are going to answer the question, what is a network topology? A physical arrangement through which various endpoints and links in an enterprise network communicate with each other. What is an endpoint? You may ask. Some examples of endpoints are mobile phones, desktop computers, virtual machines, embedded devices, and servers. Going through this video, if we have another important word that needs explanation, it's going to be shown at the bottom of the screen so that you can pause and read it so that you can understand what we are talking about. Now, it is important to know the topology of the network because the topology of a network can affect its functioning. The topology can help the IT team in charge to determine the problems that occur. And the topology helps in the configuration of a telecommunication network. The topologies that we are going to talk about today are point-to-point, bus, ring, star, tree, mesh, and hybrid. The point-to-point topology is a simple topology that links two nodes directly and reserves the entire bandwidth of the connection for them to communicate with each other. Also, this topology relies on a cable or wire that connects the two endpoints. Here we have an example of point-to-point topology, how it may look like in a scheme. And the pros of having a point-to-point topology is that you have superior bandwidth because only two nodes use the link. You have high speed when compared to other types of network topologies. It is simple to implement and easy to maintain and handle. The cons are that it is only applicable for small areas with nodes physically close to each other. It has high dependence on the common link, and it is only useful if the network has two nodes. If the network has three or only one or four or more nodes, it cannot be implemented. The bus topology is the one that has all nodes linked using a single cable with a terminator on both ends. This configuration is heavily based on the single cable that has all the endpoints attached to it. Here we have an example of how it may look like if you are designing a bus topology. The data is transmitted from one end of the cable to the other, as you can see here, and it is broadcasted through the backbone, the central cable. Only the endpoints that recognize the address uses the data that is transmitted from one endpoint. The other devices don't register it. And once the data reaches the end of the cable, the terminator removes it to prevent signal bouncing, which can be a problem in the bus topology. The pros of using a bus topology are that it is easy to add new devices and remove existing ones. Failure in a few devices does not affect other devices or the network because they can be removed easily. It is less cable when you look at other types of topologies, you use less cable. The cons are that device failure and other network fails are difficult to locate. Damage to the cable can bring the entire network to a halt, and you have low privacy because of the broadcasting. The ring topology has each node linked with its neighbor. It can be unidirectional or bidirectional. This type of network topology is usually used for smaller networks. It usually uses a token passing to regulate data flow. The token is very important for this topology. The token is transferred from one device to the next, and only the node with a token can transmit data. The pros of the ring topology is that you have circular flow of data that minimizes packet collision. Unidirectional ring topologies feature high-speed data transmission, and you have lower chances of data loss. The cons are that if you have a single failure in the cable, it can disrupt overall network operations, and unidirectional ring networks, you see data packets pass through numerous nodes before reaching its destination. The fourth topology, the star topology, in which all nodes are connected to a central router or switch using a communication link. Each node needs a separate wire to establish a point-to-point connection with the router or switch. If one endpoint wants to transmit data, it must go through the router or switch, as you can see here in the picture. This is the router or switch that transmits the data to whichever endpoint device it has to be delivered to. The pros of a star topology is that it is an easy network maintenance and management. It has an easy network maintenance and management. Failures affect only one device, and problem areas are located fast because of the switch or router. Adding new devices is simple. The cons are choosing the right central hub is a vital problem because you need to have the exact type of ports so that all the devices are connected correctly, which is very hard to find if you have different types of devices. It has a higher requirement of cables and connectors, and failure located at the central hub brings down the entire network. The tree topology, in which nodes are arranged in a configuration that resembles trees, branches, leaves, trunk, etc., suitable for large networks such as offices, university campuses, and hospitals. This is an example of a tree topology. Here, so that we can understand it better, here we have the supposed trunk. Here we have the three branches, and here we have the leaves, being the most far from each other. The pros of a tree topology is that it is ideal for nodes that are grouped together. It has a superior scalability, more nodes and hierarchies can be added. It has easy fault identification. And the cons are that large volume of cabling and numerous hubs are required because we have systems and subsystems to each level of the topology. It is difficult to configure and maintain, and failure of the central backbone trunk, as we said before, brings the entire network down. Now we have the mesh topology, in which all the nodes are interconnected and can send and receive their data and relay data from each node, from other nodes. Here we have an example of a mesh topology. You can see here, each device is connected to the other, as we said before. The pros of a mesh topology is that it is extremely robust and redundant, highly intensive data transfer due to dedicated point-to-point links for all devices, and it has a robust security and privacy. The cons are that it requires many cables and input-output ports. It has a time-consuming installation and maintenance, and it is cost-intensive. Now, the last one is the hybrid topology. It features characteristics of multiple other topologies, most common star ring and star bus. And here we have an example. Here is the star bus part of the hybrid. And here we have a star ring part of the hybrid. The pros of having a hybrid topology is that it combines the advantages of multiple topologies, can be tailor-made to suit specific network requirements, It is highly flexible and scalable if implemented correctly. And the cons are that depending on the configuration of such a network can be resource intensive, potentially complicated designs that could make it could have a complicated design that could make troubleshooting difficult, and requires compatible cabling and other hardware for inter-topology links. Thanks for watching my video and subscribe. And if I have time and ideas, I would like to make more videos like this so that everyone and me also can learn more about networks.